So we'll do that today. We learned before that if you declare a variable as char type, 1 byte of memory will be allocated. Int type will get 4 bytes, and float type will also get 4 bytes. Even though float type and int type get the same amount of memory, float is considered to be larger data type than int. So whenever there's a float and int type operands, both of them will be converted to float before carrying out the operation. So let's go to the other variable types. There are other variable types. Uh, they are designed to allocate different amount of memory. So if you don't need for example, suppose that you have an integer type number, but the number is small enough that you don't want the system to allocate 4 bytes of memory. If you declare the variable as integer, it will allocate 4 bytes. So if you have a lot of integer type variables and you declare integer type, many integer values are going to be used in the program, but they're all small numbers, then you don't want 4 bytes to be allocated for all of them. So you can ask for 2 bytes instead. So things like that are allowed in C++. So let's look at some of those types. Short int. If you declare a variable as short int, or simply short, instead of short int, you can just say short. Then that means you're asking for 2 bytes of memory for that integer number. So it's an integer type variable, but you will only get 2 bytes for that. And if you declare it as int, you get 4. Long int would be 8 in larger computers, but in microcomputers, it'll still give you 4 bytes because microcomputers have limited memory. One second. Okay, so among the integer types, now there are two new ones we learned. Short type, which means integer type, but only 2 bytes will be allocated. Long int, you declare something as long int when the number is very big and you want larger memory. You will get 8 bytes in normal computers. Only the microcomputer doesn't give you 8, it will give you 4. Similarly, in float, normally you declare a variable as float type, you'll get 4 bytes. But sometimes you want more accuracy, you want more decimal digits to be carried out in your calculation, then you declare double type. Double type will get 8 bytes of memory. If you want even more accuracy or much larger float type numbers are going to be handled, then long double. Again, long double only gives you a 16 megabyte of memory if you're using a larger type computer like mini and mainframe, but in microcomputers it will be 8. The long int and long double are not very useful for us because we are using microcomputers. So they're useful only if you're using larger computers. So for us, it's more important to know all the details about these char and short int and int. Char type variable can be used to store integers, as I explained in the last class. You can store integer in a char type variable and do calculation with it. You can do everything the way you manipulate integer after storing it in a char type variable. The reason for using char type is to minimize the use of the memory. If the number is very small, then char type will do it. Short type is good for slightly bigger numbers. We will see in a minute what are the largest numbers that will fit in these memories. And int type, you use int type if normally, most of the time we use int type, but you now have these other choices. Okay.
So you would use short int to make the program faster?
Not necessarily faster, but you'll be using smaller amount of memory. So if if your program is going to be using a lot of numbers, then you may want to use small amount of memory. But it doesn't really make much difference in the speed, but it's more memory efficient. That's what it means. The minimum amount of memory is being used. So learning to use minimum amount of memory is important, and that's going to be part of our discussion today. So going on to examples, suppose that we need a program to add two numbers, 365 and 132. So these numbers are small, as you can see, but what is the largest number that fits in 1 byte of memory? We calculated these earlier. I can quickly show you that here. The 1 byte of memory means 8 bits. Only 8 bits are available. So the largest number that fits in 1 byte of memory will have 8 ones in it. So 1, 1, 1, 1, 1, 1, 1, 1. This is the largest number in binary form that fits in 1 byte. So you have to convert it to decimal equivalent. So this one corresponds to 2 to the 0, the other one is 2 to the 1, and all the way to 2 to the power 7. When you have 8 bits, the highest power is 2 to the 7. And we learned the formula that 2 to the 0 plus 2 to the 1 all the way to 2 to the n would be equal to 2 to the n plus 1 minus 1. This is the formula we discussed before. So if you apply that formula, this will be equal to 2 to the power 8, one more than the largest power, minus 1. And 2 to the 8 is 256, minus 1 is 255. So 255 is the largest number that fits in 1 byte of memory. And that's why all the characters have decimal equivalents that are number 1 to 255. All those numbers 1 to 255 correspond to some characters. So in other words, the decimal equivalents of all the characters that we use are coded in, have corresponding decimal codes that go from 1 to 255. Every number between 1 and 255 correspond to some character. So so anyway, the point is 265 is the largest number that fits in 1 byte. So to store this number, 365, I have to use more than 1 byte because it's more than 255. So 132 fits in 1 byte. So if I want to use minimum amount of memory in my program, then I have to declare short in type variable, num1 for 365. And I can store the 132 in a char type variable. Like I said before, you can store integer in a char type variable, and you can even do arithmetic with it. That will be allowed to do arithmetic with the char type variable. So I want to add these numbers. So according to our program, we want to use a program that uses minimum amount of memory to add these numbers. Our program is going to be just adding these numbers. So I'm declaring short int type variable for the first number, char type variable for the second one. And to put the answer, I'm declaring short int. I'll explain in a minute. Num1 is short int type, num2 is char type. So this, since they are not matching type, it'll convert both of them to the larger type, which is short int. So the answer will be short int type. And that's why I declared my sum as short int type, so that I can have the answer without any conversion. And then see out sum. So the result will be produced by this correctly. And the point is here, we are using minimum amount of memory. We didn't declare the variables as int. If you declare them as int, you'll be using 4 byte for each one. Another point I want to make is this. I declared this as short int and the other one as char, but when it comes to this conversion right here, you can see that when you're doing the addition, they're both going to be converted to short int, the larger type. So even though the num2 is stored in char, it is being converted to short in here. So I am going to use, I'm going to be moving to a 2-byte memory from 1-byte memory right here before doing this addition. So therefore, there is no point in declaring one of the variables as char and the other one as short int, because they're going to be converted to larger type when you're adding. So you are actually using 2-byte for this and 2-byte for this. So therefore, you may as well declare the num2 as short int. There's no benefit in declaring num2 as char. All right. So a better programming would be to declare num1 and num2 and sum, all of them as short int. All right. So moving to the next page. So recall that the data type conversions will happen. And so therefore, I already explained that in this previous program, there's no benefit in declaring this one as char. You could have declared that as short int as well, because they're going to be converted to the same type. Okay, so a better way to write that same program is to say short int num1, num2, and sum. All of them are short int, and add them up and print the sum, which is the better way. All right, so going to, now we're going to understand about sign bits in the memory. We have been discussing that, discussing the numbers, how they are stored in the memory. But what about negative numbers? We never talked about negative numbers. Numbers can be negative, and therefore, whenever number is negative, the negative sign has to be stored. So therefore, when the negative sign is not stored as a symbol, there is a certain technique that the whole number will be put through a process to convert to something. If the number is negative, there's a process compiler will go through to produce another number that will be stored. Now, that process is something you will be learning in advanced computer science classes, but for our purposes, we don't want to go into that. So, but you can imagine this, even after going through that process, there will be one bit of the entire memory that will be essentially used for the sign. So you can imagine, for our purposes for this class, you can imagine one bit being used to store the sign. Let's leave it at that. And the remaining bits will be useful for the number. So if you declare the variable as short or int, or normal, using normal words, then it's going to allow that sign bit, because that number you're going to store in that variable can be negative. So therefore, it will allow one bit for the sign, and therefore only the remaining bits are there for the number, to store the number. So we said earlier that if you declare a variable as short, then you have 16 bits for the number. You don't really have 16 bits for the number. You only have 15 bits for the number, because one bit will be reserved for the sign. So so now we had to, understand the details of how big of a number will be stored in each type. We had to discuss that again, because now we know that there will be one bit reserved for the sign. So let's think about this short type we discussed before. You declare the variable as short type, then you get 2 bytes of memory allocated. And do you have all of those bits for the sign, for the number? Not really. One of the bit is allocated for the sign. So only 15 bits are there for the number part. So the largest number that fits in short type variable is not exactly 65,535 that we computed before. So let me do that again. So get the pencil. Okay, so now we have 2 bytes. This is short type variable. If you declare a variable as short, then largest number that fits in it will have 4 bits. The last 4 bits will be all ones, but in the first 4, last 8 bits will be all 1. But here in the second, you have only 7 bits. The other one is sign bit. So that means the largest number that fits in here is going to be 2 to the 0 plus 2 to the 1. The decimal equivalent will be this last one is going to be 2 to the, this corresponds to 2 to the 14, not 15. So if you simplify this, that's equal to, if you apply the formula, it's equal to 2 to the 15 minus 1. 2 to the 15 minus 1 is 32,000 something. These are things you're supposed to be able to calculate. There are homework questions on those, but I can calculate this one quickly. 2 to the 15, I'm trying to use my calculator. 2 to the power 15. 32,768. So 32,768 minus 1 is 32,767. So this is the largest number that fits in short type, if you just declare it as short type. So the range of values that fit in short type will be negative 32,767 to positive 32,767, because negative sign can be now stored. So the smallest number that fits in short type variable is negative 32,767. The largest number is 32,767. So you're supposed to be able to calculate these whenever the question asks for it. Okay, so if we don't allow sign bits, then it'll have all 16 bits available. So how's that? How do we do that? We'll see that in the next few pages. All right, so remember, if the variable is not declared, the variable is declared as short or int, it's going to have 1 bit allocated for the sign, but not the char though. Char doesn't allow signs. You can understand why. The char is designed to hold characters, and ASCII codes of characters don't have negative sign. So therefore, sign is not allowed in char. Make a note of that. No sign in char. So there's no char sign bit. And so you can only store positive integers if you're using char type variable to store them. Negative numbers cannot be stored. Okay. Now, remember, we are still at the foundation of computer science. You know, we are at kindergarten. These are all basic stuff. And we're going to be finishing up today. Section 2.5 is the last of that. And then we'll be moving on to chapter 3, and we'll start serious computer programming there. So now, because the sign bits are allowed whenever you declare a variable, what if I don't have signs? Sometimes in business applications, like, you know, you're working with all prices of items and things like that, you know that numbers are all positive. So should we have this sign bit? No, we can ask to remove that sign bit. You know, we can say all my numbers are positive, so don't use sign bit. We can do that simply by declaring the variable as unsigned type. If you say unsigned, then that means I don't have signs in my numbers, so I don't need a sign bit. That's what you're saying. So you can declare a variable by, instead of saying short int val, you can now say unsigned short int val. That means I need 2 bytes for my number, but I don't need a signed bit. All that is said right there, unsigned short int val. So you have 16 bits available, all 16 bits available to store the number if you declare it this way. And so therefore, the largest number that fits in this variable is 65,535 because of the unsigned. Only if the unsigned is missing, then the largest number that can fit is 32,767. Okay, so the same thing applies to int. You can say unsigned int, but there's no unsigned char because char is already unsigned. There's no signed bit for the char. So for int also, you can say unsigned int. So only if you say unsigned int, you have all 32 bits available for the number. All right, so moving to unsigned short type. So the largest integer that fits in the variable declared as unsigned short int type is exactly 65,535, as we calculated earlier. Similarly, if you declare a unsigned int type variable, then you have 32 bits available. And if you have 32 bits available, the largest number that fits in there is 4 billion. Only if you declare it as unsigned, then the largest number that fits there is 4 billion. If you declare it as just int, then it's not 4 billion. So let's quickly take a look at that. If I declare my variable as int val, then what is the largest number that can be stored here? 4 bytes are there, but the largest number that fit will be having 8 ones in all these. All of these will be 8 ones, but here there'll be only 7 ones. The other one is signed bit. So if you convert it to binary, decimal form, it'll be 2 to the 0, 2 to the 1, all the way to 2 to the power. This is the 32nd bit. So 2 to the power 31, if the sign bit is not there, it will go to 31, but this is 2 to the 30. So if you calculate that in your calculator, the sum of this will be 2 to the 31 minus 1, which I can quickly do that. Now, remember, you need a calculator that can calculate exponents when you're doing this in your test. This kind of question can be asked in your test. So you need to have a calculator that has exponents. I'm calculating 2 to the power 31 right now. So 2 to the power 31 equal to 2 billion 147 483 648 minus 1. So that'll be 2 billion 147 483 648 or 47. This is the largest number that fits in int type. That's the correct largest number that fits in int type. So earlier we said my questions were in the earliest sections. My questions were, what is the largest number that will fit in 4 bytes? I didn't say int type. I said 4 bytes. For that question, that answer was right. The 4 billion something. But now the question can be reworded as, what is the largest number that fits in unsigned int type? Then it will be 4 billion. So if you declare the variable as unsigned int x, then the largest number that fits in this variable will be 2 to the power, this will be going all the way up here in this picture. The 32nd bit will have 2 to the 31. So 2 to the 0, 2 to the 1, all the way to 2 to the 31. That will be the largest number that fits in unsigned int x. So equal to 2 to the power 32 minus 1. And that's what 4 billion something is, 4 billion something. I would say 4 billion, but you have to be able to produce the exact number using your calculator. And I think one of these is a homework question in this section. Anyway, so you had to be able to calculate the largest number that fits in unsigned short or just short, and then unsigned int, just int, and char, all these type of variables, largest number that fits in there you should be able to calculate. All right, going on to example 2. Okay, now let's do this example. It says write a program that uses minimum amount of memory to multiply the numbers 345 and 452. All right, so those numbers don't fit in 1 byte. So if you need 2 bytes for one of them, then you may as well use 2 bytes for both of them. So that's what I'm doing. And they're both positive, so therefore I'm declaring unsigned short K for the 345, M has 452, val. And val is also unsigned short, because when you multiply 2 unsigned short type numbers, the product will be also unsigned short. So val equal to K times M and see out val. Okay, so it looks right? It looks like the program will work. And you're supposed to use minimum amount of memory, and that's what you're doing by declaring the variables as unsigned short. But there is a problem with this. Can anybody tell me what the problem is? This is not going to work. Anybody see the problem?
No, I don't see it. I'm
All
sorry.
right. Yeah, I can understand. It's not easy to see. The K times M, we're multiplying these two numbers. We are multiplying. If you're adding, no problem. Hold on. Gray 42. If you're just adding them, it would work, but you're multiplying them. When you multiply large numbers like 345 and 452, that's bigger than 65,535. So in other words, it's not going to fit in that short
In the
type.
short, yeah, no, unsigned short, right?
Right.
Okay.
Short type is not going to be big enough. So what will happen? The problem is, we wish the system will give us error message, overflow error message. It's an overflow situation. But when overflow happens, it doesn't give you any error message, because here's the reason. I mean, it's not that they couldn't design the compiler to give you error message in this kind of situation. The problem is the overflow is sometimes taken advantage of in some programming techniques. And so overflow is allowed. And that's why it's not an error. So it's not going to give you an error message, but it is an error as far as we are concerned, because you're going to get wrong answer. Why wrong answer? Let me explain on the board here. Let's say some number has, basically the number is not going to fit in this 2 byte of memory, right? So when the number doesn't fit on 2 bytes of memory, the system is designed to fit whatever that fits. In other words, if there are, let's say, 17 bits in your number, so 17 bits are not going to fit in 2 bytes of memory. You allocated only 2 bytes. So what it does is it will just fit whatever it can fit, and it'll leave out the bits that don't fit. In other words, the bits in the front will be chopped out. Only the latter fit bits will be stored. What does that mean? The answer is wrong, basically. So that's what's going to happen. This program is not going to produce any error message. It will simply give you an answer. You are going to get an answer for this val, but it's going to be a wrong answer. Why is that? Because the number of bits in the answer didn't fit here, so it only stored whatever that fits. That's what happened. Students keep coming late, so I have to keep writing down their names.
Can you store it into a long int?
You can. Uh, so I mean, if you start with long int, then you are wasting a lot of memory. So that's why the programmer has to figure out what is the smallest amount of memory that will produce correct answer. In this case, int will do, right? So the short cannot be used. We have to use int.
Is it possible to start with unsigned short and then store to a new one to like a long int?
Yes. Well, you had to make them, see, in the K and M, if they're both short, then the answer would be produced as a short type answer. So right there, you're going to get the wrong answer. It's not storage. It's not here. It's not, the problem is not at val. Problem is right here. This, when it produces the answer will be right there stored in a short type storage temporarily, and then it will be copied into val. So the operation itself is going to go wrong. So you had to have one of them larger type, one of them int, then both of them will be converted to int, right? So you had to have K or M declared as int. So you may as well declare them both as int. So here the short type is not good. You have to declare all of them as int type to get the right answer. So if I give you a problem like this in the homework and ask you what is the output of this, your answer has to be wrong results. That's your answer. Okay, don't give me the actual product of 345 and 452. You're not going to get that. You'll get a wrong answer. So the answer for this will be wrong results or wrong answer, something like that. And then if it asks you for a remedy to get the right answer, the remedy is to change the unsigned short here to what?
To int, both of them int, right?
Right,
Yeah.
int or unsigned int, either one will work. Unsigned int will be fine because the numbers are positive. So unsigned int, even int will be fine. You just saving a bit of memory by doing unsigned. So that's not important. So either answer unsigned int or unsigned int will be correct answer as a remedy for this problem. And you have to be able to answer the question as wrong answer will be produced. It's not error. If you say error message, that's wrong. You don't get error message for this. There are problems in the homework like this. So I just wanted to explain that. Okay, going on to the next example. Consider this program. Int k equal to 345 val. They're both int now. And then unsigned short int m equal to 21. Now clearly 21 is small enough to fit in unsigned short. And then we are doing val equal to k times m and see out val. Okay, so what happens here is m is unsigned short and k is int. So in this, to do this multiplication, it's going to have to change m to int because remember, if both operands have to match the data types of the operands. So if one of them is different from the other, they will be both converted to larger type. The int is the larger type here. So this is int type, so therefore m will be converted to int type. The product will be int. So it'll be stored in val. Val is already declared as int. So everything is fine. This will produce the correct answer, but the declaration of unsigned short int here is useless because even though you're using short int to store that number, it is getting converted here to int. So that 2-byte memory is changing to 4-byte right before doing this multiplication. So therefore, it is not really beneficial to use the unsigned short int. So just declare them as int. All of them should be declared as int in this case. But if the problem says write program to multiply these two numbers 345 and 21 using minimum amount of memory, then what would be the data type you would use?
Short int.
Short int, that's right. So if the question is to use minimum amount of memory, then you declare all of them as short int. There's no use of declaring one as short int and the other one as char or anything like that. So declare all of them as short. All right. Okay, so unsigned, let's look at this program. Unsigned showed A equal to 235, B equal to 450, and C equal to A times B. You're multiplying them. And then product equal to, the product is printed. Now, I explained a similar problem earlier. What is the problem? This program will work and it's not going to produce right answer because 235 times 450 is not going to fit in unsigned short type memory. So the result it produces is going to be the bits that fit into 4 bytes. So remaining bits will be simply eliminated, simply dropped. And that means your answer is going to be wrong. So here, actually, I ran this program. The correct answer should be 105,750. And the answer produced by this program was negative 25,322. How did you get the negative? Because, you know, when you drop some of the bits, the bits actually that end up getting stored have a 1 in the front. That's what happened. If you have a 1 in the front, the sign bit, then that's a negative number. If you have 1 in the sign bit. If you have 0 in the sign bit, that's positive number. Now, that I didn't go into that 1 and 0 business because that's something you will learn later with all the details, and I shouldn't be giving you incorrect information. But in fact, in the sign bit, you will end up getting a 1 if the number is negative. In the sign bit, you will end up getting a 0 if the number is positive. So anyway, I ended up getting a 1 in the sign bit, and therefore it gave me a negative number as answer. So the point is, the answer will be wrong. You're not going to get the right answer if there is overflow happening. So if there's a question like this in the homework, go ahead and use a calculator to multiply those numbers and see whether it fits in 2 bytes of memory. The largest number that fits in 2 bytes of unsigned short type memory is 65,535. So if it is bigger than that, then you know that overflow is going to happen, and therefore the answer will be wrong. That's your conclusion. Okay, so moving on to the data type hierarchy. So now that we have learned all these different data types, what is the larger data type and what is smaller data type? You need to know what is larger than what, because in arithmetic operations, the smaller types will be converted to larger type. So the largest type is long double. Next largest is double, and then float. Unsigned long int is smaller than float. See, float gets only 4 bytes. Unsigned long int is supposed to get 8 bytes, right? But it's considered to be smaller than float. All the floating types are larger than all the integer types, no matter how many bytes are allocated. So unsigned long int is smaller than float, and then unsigned int, and then int. Now, what's the difference between unsigned int and int in terms of memory?
Unsigned is like one extra spot.
Unsigned int has
One extra like spot.
right one more bit available than int. Unsigned int has one more bit available to store the number than int. So therefore unsigned int is bigger. So if you have unsigned int and int type two numbers, one is unsigned int, the other one is int, they'll be both converted to unsigned int. So you need to make sure they can both fit in that. Okay, unsigned short is smaller than int, and short is even smaller. So there's a 1 bit difference between unsigned short and short. And the char is smaller than short. Char is the next one. I think that didn't fit in here. So the smallest data type is char. So that goes next to this. So this is the hierarchy, and it's common sense. You don't really have to memorize anything here, all based on the size of the memory, except that all the integer types are smaller than the float types, smaller than all the float types. Okay, so let's move on to our warm-up exercise. It says write a program to multiply the numbers 380 and 200 using minimum amount of memory. Okay, you can tell me just what data type to use.
Short int.
Okay.
I will say
Everybody agree?
unsigned long int.
Why long int? No,
Or remultiplying? Isn't it gonna?
but
Oh
the
yeah, okay. I see. I see. Yes, the numbers that we're starting with is supposed to be okay.
yeah,
Okay,
if
I see.
you can if I multiply them, 76,000 is the value of the product. So can the product fit in short int? 76,000?
No.
No. What is the largest number that fits in short int? You can just give me a
Isn't it 32,000?
32,000 and change. Yes, 32,000. That's the largest number that fits in one byte. I mean, 2 bytes. Or in other words, short int. Only if you declare it as unsigned short, then you will be able to fit 65,000. But this number, this product is 76,000. It's 76,000. And that doesn't fit in even unsigned short, right? Unsigned short can handle 65,000. This is 76,000. So it doesn't fit in unsigned short. And that's why the answer needs to be stored in a int type, right? That's the next larger one. So if the answer needs to be stored in int type, then all numbers should be stored in int type. So therefore, the program should declare all the variable as int x equal to 380, y equal to 200, and then answer ans, and then ans equal to x times y, all int. Even though problem tells you to use minimum amount of memory, this is the only way to have it. Just because the problem says use minimum amount of memory, don't try to use short int, because getting the correct answer is more important than using minimum amount of memory. So you still have to get correct answer. So therefore, this problem, the solution for this problem is what I just wrote. Int x equal, all variables will be int. Cout ants. This is your program using minimum amount of memory. Okay, second one says, write a program to multiply the numbers 35 and 55 and 20 using minimum amount of memory. Okay, how would you do that?
Can you use char for that one?
Okay, can we use char for all of them? Anybody? One student says we can use char for all of them.
No, because we'd have to convert the char back into a number.
No, that's not the reason. Let me go ahead and write the program with the char.
Sure.
Char x equal to 55, y equal to 20, and then declare a z for the answer, and then z equal to x times y, and cout z. Okay, only problem is it's going to print a character, because z is character type. It's going to print character, but I want to get the numeric answer. All I have to do is just convert it to int right here to get numeric answer, int z. Okay, so I'm using char type variable to store all of them and to do the product. Multiplying char type variable by char type variable, is that wrong? No, you can do multiplication with characters because characters correspond to numbers. So whenever you do arithmetic operation with any character type variable, it will be converted to number, appropriate associated number will be used to do the multiplication. So therefore, there's nothing technically wrong here. This is fine. There's nothing wrong in using char. So what's wrong in this program? Why is this not going to be right? We can't really use char type. Why? What's wrong?
Is it because of the how much memory it uses with char type?
Yeah, 1 byte. It's going to use 1 byte, and 55 fits in 1 byte, 20 fits in 1 byte. Remember, 255 is the largest number that fits in 1 byte, right? So where is the problem?
The answer is bigger than the char.
Exactly. The answer is too big. The product here is equal to
1100.
1,100. 1,100 doesn't fit in 1 byte. 255 is the largest that can fit in 1 byte. So what is the size of memory we need? 2 bytes, right? 2 bytes of memory. That means
Unsigned short int, maybe?
unsigned short int for all of them. Exactly. Unsigned short. Unsigned short X, Y, Z. All of them have to be unsigned short. And then X equal to 55. Because if one of them is unsigned short, they're all going to be converted at some point. So no point in using another type. X equal to 55, Y equal to 20, and then Z equal to X times Y. So just declare unsigned short, everything will be fine. So you should not just look at the numbers only. You should look at the answer, how big the answer is, and do we have enough memory for that? That's what you need to focus on. Now, let me ask you a question. Let me go over some quick questions here. Example problems. I should have had it in the presentation. I don't, so I'm going to make up on the board. Okay. Suppose that I write something like this in my program. Char X equal to 97. And then Y is another char. And then I say Y equal to X plus 3, semicolon, C out Y. Okay, what will be printed by this is the question. If there is anything wrong, this is not going to be producing an answer, then you had to say error. And sometimes if it is error, the homework question will ask you to explain why. If it is not error, then tell me what the output will be. That's the question. 97 will be converted to character, right? Because unchanged sort x equal to 97. This is valid, but the 97 will be converted to character. Anybody remembers what that character will be? '97 corresponds to what character? You don't really have to memorize those. They will be given, when you can look up when you're doing homework. If it is test question, then the corresponding letters will be given. Uppercase A through uppercase Z are 65 to 90.
Lowercase d, right?
Say again. So
Lowercase d.
Lowercase a, because A to Z are 97 to 122. Okay. This information will be given to you if it is test question. So this 97 corresponds to lowercase a. So in this statement stores A in X. That's what you have stored. So when you add 3 to it, that's what you're doing here. You're adding 3. So when you're adding 3, the X, even though X has a character, that's going to be converted to number right here. Because remember, in any operation, both operands have to match. So X plus 3, the 3 is recognized as int type. And therefore, this has to be converted to int type. So therefore, the 97, the character A will be converted to 97 here, and the 97 and 3 will be added. So now you're getting 100. So the value is
I see.
100. I'm sorry, go ahead.
No, I see now. I see what you mean.
Okay, and the value will be 100 for X plus 3. And then you're storing it in a character type variable. So the 100 will be converted back to character. And 97A, 98 is B, 99 is C, 100 is D, lowercase d. So therefore, basically the Y will be getting a D. D will be stored in Y. And that'll be printed now. So what is printed by this program? A D, okay? So that's what I'm trying to explain. You had to look through all the details of how things are going. So basically, this program tells you that if you take a character lowercase a, which is same as 97, if you add 3 to it, you will be moving to D. So you can, so if I want to move up 3 characters, just add 3. Then you'll be moving up by 3 characters. You can add number to a character. Nothing wrong with that. They'll be both converted to number and the addition will be done. Okay, feel free to ask any other question on that.
Hey,
Okay.
Professor.
Yeah.
I completed the project, but I couldn't submit it. I was like 5 minutes late. Is there any way I can still hand it in?
Yes, I am actually giving everybody a chance to hand it in later today because of this rounding thing that's supposed to be done, and some of you didn't make the corrections in your. So by the way, let me remind you, the corrections that are posted on the blackboard, you must do them on your copy of the book. Otherwise, you're going to run into this problem over and over. This is the last time I'm going to forgive and give you a chance to correct the mistake. In the future, I won't be doing it because it makes my job difficult. So you need to make those changes in your copy of the book and do the right problems in the future. So this time, because of the rounding requirement, your answers must be rounded to the nearest 100th. And some students missed it because they didn't make the change in their book. So therefore, I'm allowing everybody to be able to turn in a newer version by later today, like sometime around 8 p.m. or so.
So I haven't turned in the project at all.
Okay,
Do
so
I?
I'm going to change the due time to
Okay.
later time today.
All right, cool. Thank you.
You'll have a chance to submit. And others who have submitted will have to tell me if you want me to remove it. Remove the older one so that you can submit a new one. It won't allow you to submit a new one if the older one is there. There can be only one copy of your assignment.
I sent you the email already with the PDF.
You
Right?
can either send me an email request or tell me at the end of class that you want me to remove it, and I will remove the older one. And then you'll be able to upload a new one. This is the last time I'm giving you extension because of your mistake. In the future, it won't be given. It makes my job difficult. So in the future, I won't be able to do it. So I have graded. If you turned in, some of you turned in yesterday. If you turned in yesterday, I graded them. And if you lost points because of the rounding, then you still have another chance to turn in a newer version. So you can ask me to remove the older one. All right, any other question? Okay, so now let's talk about the test. The test is going to be Monday. Right now we have completed everything we need to, that's going to be covered in the test, all of chapter 1 and 2. Chapter 2 finishes right here. So you have a homework assignment. I will be posting the link today for problems on section 2.5. And then next class, essentially we will be going over the practice test. You have to have your practice test all done and have your questions ready. The practice test means the review, chapter review of chapters 1 and 2. I think that's what it's called. The document is called Review of Chapters 1 and 2, and it's posted on Blackboard. There is a review at the end of chapter 1 and 2 in your book. But this version I have posted on Blackboard is a better version, more improved, and also it has answers for all of them. But just because the answers are there for all of them, just don't read the problem and the answer. You know, that's not the way to learn this. This is just like a math course. You really have to do it to learn. So do all of them first, and then compare the answers to see if you got them right. So take it like a test. But before taking the review like a test, I strongly advise you to go over all the homework assignments and make sure you understand the ones you got wrong. There's always a comment from me explaining what went wrong in that problem, and learn from that so that you won't make the same mistake in the exam. The exam questions are going to be very similar to your homework questions, right? Most of them, almost all of them. But the programming questions are new. I mean, new program you have to write. But that's also similar to the programs you have done before. It's not going to be entirely new. If you go over the previous programs and homework questions and everything, then you will be prepared well. So I advise you to go over all of the homework. They're all still there. You can access them and look at them. Look at my comments and everything. Learn from that to do it the right way, and then do the practice, the review like a test, and then compare the answers. And if you're getting all of them right, then you're prepared. And if you're getting them wrong, then make sure you understand why that was wrong and what's the right way and all that. That's how you prepare. So, basically, reading the book is not important. This is something, this is a skill. The skill doesn't come through reading. It only comes through practicing. So that's why the review questions are there. So please review the homework first, homework and projects, all of them you have done. And then do the review as if it's a test and compare the answers.
Is it gonna be all 90 questions?
90 questions. Oh no, the review is larger than the test itself. The test itself will have about 50 questions. The 50 is still, that's not long, because many of the questions only require like 2 seconds to answer, right? For example, what is the largest number that fits in 1 byte of memory? What is the largest number that fits in char type memory? Something like that. It only takes a couple of seconds to answer. And then what is the hexadecimal code of this number? Well, that would require a little bit of work. So you need to have a scrap paper in front of you to do the work. So that would require like, half a minute maybe. But many of the questions are like seconds, few seconds is all it takes.
Excuse me, Professor.
Yeah.
Is there any other essential information that we need to know? Because I have class in 1 minute and a different class in 1 minute.
Our class ends in 1 minute. You have 10 minutes after that.
Oh, I'm sorry. You're right. Wow, my bad.
Yeah, basically the test is going to be on chapter 1 and 2. No new information. So the kind of questions you have seen in the homework, that's what you're going to have. Of course, you'll have to be able to find the largest number that fits in 1 byte of memory, 2 byte of memory, or unsigned short, unsigned int. What's the largest number that fits in there? All those things that we went over today. Things like that. And writing output of little codes, like I just went over this question here, writing the output of this little code. Those are going to be there. Sometimes if the output is going to be a float type number, but it's a whole number, like 5. So the actual output is 5 point. The point cannot be missed. If you write 5, you get partial credit, but not the full credit. When the answer is going to be float type, you have to include a decimal point with the answer. Things like that you have to remember. But we can go over more of these questions in the next class, because next class is basically going to be review. Review in the sense I'll be going over questions you have from the reviews, review chapter 1 and 2, and we'll go over these homework questions of homework 6 and 7. The 7 is going to be the one on this section, 2.5. You're going to do it for next class, but we can still go over them on the next class because the following class is test. So we'll go over them. We'll go over the 2 homework 6 and 7 in the next class, along with the review questions. Okay, so do the review and have your questions ready for the next class.
Can I ask a question? How much time is the test?
The exam will be 1 hour and 15 minutes. I'll give you some extra time. The only way to get extra time is to start early, right? So I recommend starting at 7:30. Everybody agree with that? Would you like to start at 7:30?
I don't mind.
Okay, then we'll start the test at 7:30 so that you can have extra time of half an hour, and that's it. When that 1 hour and 45 minutes ends, the test will automatically quit. It'll terminate. You won't be able to do anything after that. It'll submit and terminate. So everything will be saved, and it'll be gone.
On Blackboard, correct?
Right, it'll be on the blackboard.
Okay.
Okay. You're not supposed to have anything in front of you. Any notes on your computer screen or anything is not allowed. And while you're taking tests, you're not allowed to use any other software or website or communication media, texting, things like that are prohibited. Remember that. A violation of that will end up failing you. Last semester, I failed 6 students because they cheated during the exam. They actually communicated. Can you believe that? You know, I mean, in class exams, people don't do that kind of cheating, but now there are ways, and they were doing it, and I was able to figure it out just by looking at their exams, and I failed them. Okay, so the punishment is severe if you violate the rules. All right, so have your questions ready for next class. Next class is all discussion, and the following class is test. All right, enjoy the rest of the day. I'll see you on Wednesday.
Thank you, Professor.
Yep.
Oh,
Thank you,
Thanks,
Professor. Bye.
everybody.
Have a good day, Professor.
Yep, bye-bye.
could you
Good
remove
day.
my project so I could resubmit it?
Who's that, Anissa?
Have a nice day. Bye.
Okay. Okay, Anissa, you want me to remove. Anybody else? If you want me to remove your project, let me know.
You remove mines, but remember it says that the time limit, I can't submit anything.
He's changing that.
I'm
Okay.
changing the time to later.
Okay.
Okay.
Professor, me too.
Have a good day.
You too. All right, Anissa, Christopher, and who else?
Me, Calvin.
Kelvin. Kelvin, okay.
Thank you, Professor.
You're welcome. Have a nice day.
You too.